Internet of Things, or IoT, is a network of physical devices connected to the internet. These devices are embedded with sensors, software, and unique identifiers that enable them to collect data from their environment and exchange information with other devices and systems without requiring human intervention. Think of IoT as giving everyday objects like smart thermostats, fitness trackers, security cameras, and refrigerators the ability to connect, communicate, and share information. The main idea behind IoT is to create intelligent networks where devices automatically gather data, process it, and take smart actions based on what they learn. This technology is transforming how we live, work, and interact with the world around us. An IoT system is built on four essential components working together. First, sensors and devices collect data from the physical environment. These can measure temperature, motion, light, humidity, or many other factors. Second, connectivity transmits this data using networks like Wi-Fi, Bluetooth, Zigbee, LoRaWAN, or 5G. Third, data processing analyzes and makes sense of the collected data, often using edge computing or cloud platforms. Fourth, the user interface provides dashboards, mobile apps, or web applications where people can interact with the system and receive information. All four components must work seamlessly together for an IoT system to function effectively. Internet of Things is already transforming many areas of our lives. Smart homes use IoT to control lighting, heating, security systems, and appliances automatically. Healthcare uses IoT devices to monitor patient vital signs and health data remotely. Smart vehicles are connected cars that can communicate with traffic systems and provide real-time navigation. Manufacturing uses IoT for predictive maintenance and automating production processes. Agriculture uses soil sensors and smart irrigation to monitor crops and optimize water usage. Smart cities use IoT networks to manage traffic flow, optimize energy consumption, improve waste management, and enhance public safety. These applications show how IoT is making systems smarter and more efficient across every industry. With billions of devices connected to the internet, security becomes a critical concern. Weak authentication means many IoT devices use default passwords, making them vulnerable to attacks. Lack of encryption allows hackers to intercept sensitive data being transmitted between devices. Malware and ransomware can infect IoT devices and turn them into botnets for launching attacks or demanding ransom. Limited updates means many devices never receive security patches, leaving them exposed to known vulnerabilities. Data privacy is a growing concern as IoT collects massive amounts of personal information. Finally, the large attack surface means that with billions of connected devices, attackers have numerous entry points to compromise systems. These challenges require careful attention to security practices when deploying IoT solutions. To protect IoT systems, organizations must implement several security practices. Strong authentication includes multi-factor authentication and robust credential management to verify that devices and users are who they claim to be. Data encryption protects information both at rest and while traveling across networks using strong encryption algorithms. Regular patching ensures firmware and software updates are deployed quickly to fix security vulnerabilities. Network segmentation isolates IoT devices from critical systems to limit damage if an attack occurs. Continuous monitoring uses real-time threat detection to identify suspicious activities and anomalies. Zero-trust architecture assumes that every device could be a threat and verifies all devices before allowing them access. Together, these solutions create a comprehensive security framework for protecting IoT systems. Internet of Things is evolving rapidly with several exciting trends. 5G and 6G networks will provide ultra-fast, low-latency connectivity, enabling real-time applications that weren't possible before. Artificial intelligence and machine learning will be embedded directly into devices, allowing them to make autonomous decisions without always relying on cloud processing. Edge computing will process data closer to where it's collected, reducing delays and improving response times. Sustainability focus is driving development of energy-efficient IoT devices that consume less power while maintaining high performance. Digital twins create virtual replicas of physical systems, enabling simulation and optimization before making real-world changes. The IoT market is expanding rapidly, and these trends will shape how the technology evolves in the coming years. Despite tremendous potential, IoT faces several industry-wide challenges. Interoperability remains difficult as devices from different manufacturers struggle to communicate seamlessly with each other. Standardization is lacking because there isn't a universal standard that all IoT platforms follow, creating fragmentation. High costs make it expensive to deploy IoT infrastructure, especially for smaller organizations. Connectivity gaps exist in rural and remote areas where network coverage is limited, preventing IoT deployment. Energy efficiency is still a challenge for battery-powered devices that need to operate for long periods without recharging. Skill shortage means there aren't enough qualified IoT developers and specialists to meet growing demand. Addressing these challenges is essential for widespread IoT adoption. Internet of Things is creating numerous career opportunities for professionals. IoT architects design IoT platforms and strategies with overall technical leadership responsibility. Embedded systems engineers develop firmware and integrate hardware with software for IoT devices. IoT network engineers build and maintain the communication infrastructure connecting IoT devices. IoT security specialists protect IoT systems from cyber threats and vulnerabilities. IoT data scientists analyze the massive amounts of data generated by IoT devices to extract valuable business insights. IoT solutions engineers design and implement custom IoT solutions tailored to specific client needs. These diverse roles mean there are many career paths available for people interested in working with Internet of Things technology. The Internet of Things market is experiencing explosive growth. In 2025, there are approximately 21.1 billion connected IoT devices worldwide. This number is expected to grow to approximately 40 billion devices by 2030. The market size in 2025 is around $875 billion, with projections exceeding $2 trillion by 2030. The annual growth rate, known as compound annual growth rate, or CAGR, is projected to be 16.9% through 2030. Key drivers of this growth include 5G network rollout providing faster connectivity, artificial intelligence integration enabling smarter devices, edge computing reducing latency, and increasing focus on sustainability. These statistics demonstrate that IoT is one of the fastest-growing technology sectors with enormous economic potential. Here are 4 key takeaways about Internet of Things. First, IoT is a transformative technology that connects billions of devices to create intelligent, automated systems revolutionizing industries and daily life. Second, security is critical because strong authentication, encryption, and continuous monitoring are essential as the number of connected devices expands. Third, there is a massive market opportunity with the IoT market projected to exceed $2 trillion by 2030, creating significant business potential. Fourth, there is substantial career growth with increasing demand for IoT specialists across multiple roles in architecture, security, data science, and engineering. Understanding these key points will help you appreciate the importance and potential of Internet of Things technology in shaping our future.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.